So that's the basic structure. And where do I get what we're going to do? Okay, so here on Canvas, you see that I have opened this video with a house description. So this video, it's something similar to what we are going to do today, but I want you to not download, but copy and paste this link on the browser, because this is what we're going to do. Okay, so the goal is to create like an axonometric view, something like that. Here we will have the first floor. We have a basement, so we will include a basement here. And this is the kind of construction that we're going to do between structural columns. Okay. So with all these layers, we have wood fiber insulation, exterior facade, rain screen. We have a cavity here, airtight. Well, we have the passive house windows and all these elements. And finally, we will work with that roof. This is a good detail. So that's why we are going to copy this. Okay, so we will use this as a template to understand what we are doing. So the first thing that we can do, we have to create the floor. The floor is the same. So that's, if we have a basement here, this is the first floor. And then once we have this, we can copy this to the second floor because it's gonna be the same. But let's try to understand this floor. Something very simple. We have these joists, okay? So what are these joists? Well, those are two structural wooden elements, probably 2 inches by 2 inches, something like that, connected by this, and this is an OSB panel or plywood, something very easy. And then we have a board at the top and another board at the bottom. So this construction, it's pretty easy, it's very cheap, it's very light, but the most important thing here is all this thermal insulation that we have when we get the facade. Okay, so we have like a couple of feet of thermal insulation here. So with this, we don't have this thermal bridge that we might have if we didn't have this this thing here. Okay, so that's what we're going to do. First, we're going to work with this floor. And but yeah, so let's start doing this and let's try to do what it takes. So imagine that we don't have this floor slab, okay? And we are going to, well, in this case, Alexis, I'm using your file. You put some columns here, concrete columns here. I don't mind. You could have used the same wall. Okay, so whatever thing. Okay, so I think I'm going to put this wall here, or I'm going to, yeah, I think it's better if I place the columns at the grid line. Okay, I think this is what we did. We don't need this column, this concrete column here. So I'm going to delete it, but it could be there. So sometimes we need a reinforcement and we could have the concrete column here, but we're not going to do it. Okay, so now I displaced this and I have to move it again. Okay, so you can start this column on the wall itself, or we can start this column on a concrete floor slab, or we can have a concrete column as we have here. But well, now I have changed my mind and I decided that I'm going to do something different. So I'm going to start this floor, okay, on the basement wall. So that's what we are going to do. Probably we'll have to change levels because you will see how the thickness of this, if we want to meet this passive house standard, we need a lot of thermal insulation. So the thickness will be different. and probably 10 feet, because the first level, what we have here is level 10 feet. It won't be enough, okay? Because we are going to start the floor on level 0, and we are going to go up. So we will have like 1 foot here, and then 9 feet won't be enough for this. So probably we'll have to move this level up, but we'll do that later. Okay, so let's do it. We have structural elements. And between the structural elements, we have to create a wall like this with all these things. So the first thing we need, you see that here we have this wooden element. So we need to, because we can't rest wooden joists on the concrete wall. Probably it will be bad for the wooden joists. So we need a transition element, and this transition element is going to be made of wood. Okay. So on this part of on this wall, I'm going to start with it's not structural element, it's a transition element between the concrete and the wood joists. So we need something like wood, because yeah, it will be good for structurally, it will be good for the wooden joist. So first, I think we need to create a section. I'm going to create a section to work on that section. So it's in architecture. No, it's in view section. I'm going to start here. Okay, so I want the section at this place. I click OK, and that's the section. I remember that you have to activate the fine detail, because if you have this level of detail, you don't see all the things that we have placed there. So it has to be fine. And I'm going to increase the crop region. And I'm going to make the scale, because we're going to work with a lot of details. Yes, I think 1/4 will be enough for all the details that we're going to place here. Okay, so we are at this point. So that's the concrete wall. That's the element, the knife, to connect the wooden structure to the concrete wall. But other than that, we will have joists here. Okay, so first I'm going to create an architecture component model in place. And this is going to be structural. Yeah, so we're going to work with the structural framing. Okay, so everything that is wooden and made of wood, we're going to apply the structural framing element. And we can click OK here. And I'm going to work by extrusion. I want to select, what kind of grid? I don't know. So if we have numbers, yeah, I have to select a letter. So I'm going to work by extrusion. I'm going to select grid A, for example. And here I'm going to build just above the wall. I'm going to create a 2-inch wooden element like this. Okay, where is it? We don't know. Well, it's here. And this wooden element, I'm going to change the material category, and I'm going to use wood. What do we have here? Softwood lumber. Okay, so when we have to create something structural, it will be softwood. It can be pine or something like that, but softwood would be the right option for this. And now I have to place it in the right place. So I have to select this. And where the hell is the arrow? Here. Okay, I'm going to drag it from this point to that point. Remember that we can't go through that steel element, so I have to stop here. And with this one, I have to stop there. Okay, so just at the top of this concrete wall, I have a 2-inch wooden element, and I can go through this knife connection So if I need another one here, I will place it there. Okay. But I'm working only with this space between these two columns. Then when I'm done with this, I can copy everything there. So that's the first element that we need. If we look at this, you see that here we have this element, okay? Then above this element, we have these joists. I think we have joists like that on Revit. I don't know if I loaded those families here, but if I go to structure, beam, I did not. Okay, so let's go to insert. Load family. And here in structural framing, wood, I have different options, and we have this plywood web joist. Okay, so we have two elements, I think 2x2 inch wooden elements, and we have this web. The vertical element is made of plywood, or it can be made of OSB, or yeah, so we have other joists here, but this is the kind of joist that we are looking for. Got this? Okay, so we have this element here. So I'm going to insert this, open. And now when I go to structure beam, I found the web joist. Does it have different dimensions? We have two dimensions. One, this is 11, and this is 14 inches. I think the 11, 7/8, it's almost a foot. That will be enough. So I'm going to select this one. And where do I place it? I'm going to place it on level 0. So let's insert one of these joists here. Okay. And let's look at where we are. Okay, so it's the wrong level because it has to rest on this element. So on section 2, yeah, you see that we have to move it up. Okay, so let's move it up. We can move it like this, remove constraint, and disjoin. Okay, so if we want to move it up, okay, I'm going to do it again. So I select this. If I want to move it up, I can't. You see that I can't. Sometimes removing the constraint, it works, but in this case, it doesn't. So if it doesn't, you have to select this join. Okay, so remove constraint and click on this join, and then you can move it up. When you have a structural element that is connected to a level, if you want to move it up and down, there are different ways to do this. We can change the elevation level, or we can do this remove constraints and then disjoin, and then we can move it. So what I want is to rest this element on this thing here, okay, on this wooden element here. So I'm going to use align, this one, that one, this one. Okay, so now on the 3D view, we have the wooden joist here, resting on that element. Well, I have to place the first one beside this column, and then the last one beside this column. So if I go to level 0, I'm going to move this here. But I don't know why it moved in that direction. So I have to move it. Okay, so far, let's line it up with this axis. Okay, so make sure that it's resting on this part. And now what's the distance between joists? it's not specified, but it's a decision that we have to make. Usually, the distance between these joists is around 16 inches. So the standard is that we have 16 inches between these joists. But in this case, we have to abide by the distance that we have between columns. Okay, so what can we do here? So if I have 20 feet between two grid lines, how many inches do we have in 20 feet? So it's 20 times 12. We have 240 inches. If we divide this by 16, we have 15 joists. Okay, so well, we would have 15 joists if we had if we used the grid lines. Since we are from here to the internal face of this column, let's see that we can have 14 joists. Okay, so let's do that. I have this joist here, and there are different ways we can do that. Okay, the first way, we can use the option array. So let's do this just for the sake of using another tool in Revit. So we have the array. So with the array, first we have the linear or the radial. We are going to use linear because we are not doing a circle, so we are going to move in this direction. And then number, here we have 2. We don't need 2, we need 14. And then move to, I'm going to use the last. Okay, so I'm going to create 14 elements from the first one, this is the first one, to the last one. And the last one can here. So let's do that. And now I select this point. And I'm going to that face of this column. And I have 14 elements here. And the distance between these 14 elements, it should be something similar to 16 inches. It's 1 foot and 5.5. Yeah, almost 16 inches. So that's good. Okay, so here we have these joists. Okay, so with the array, it works. If you want to do it in a different way, I'm going to copy these 14 times. Okay, so I'm going to copy this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and the 14th one has to be in the right place. Okay, so I copied this randomly, but the first one and the last one are in the right place. So how can I make the distance? I have to take the aligned dimension and then pick the midpoint of all the joists. Okay, now move the dimensions away, and here you have to click EQ. If we click EQ, then all the distances are the same, and we have the same effect. Okay, so either way works, but the important thing is that we have 14 joists at the same distance. And the first one has to be lined up or aligned with this face of this column, and the last one has to be aligned with the face of that column. And now these joists are resting on this wooden element. Okay, so that's yeah. So I I don't mind how you get to this point. You can use the array or you can use copy and then annotate and select EQ and you have the same distance, or maybe there are different ways to do that. But the goal is that we have 14 joists at the same distance resting on this wooden element that we have created at the top of the wall. Okay, so what's next? Let's look at this. So we have the joist, we have this element, and you see that, we can see these joists. So there's some wooden element here hiding those joists or connecting all these joists at this point. Okay, so let's do that. If we are in the section now, this is where we are. This is the joist. This is the wooden element. Okay, so we need something here to connect all these joists. Okay, because we can't see all these here, so we need to cover all this part. But now we have the requirement of the thermal insulation. So what I'm going to do is to create thermal insulation here, and then I'm going to cover this with some wooden element like that. Okay, so I need to do two component model in place. So I go to architecture, component, model in place. I don't have any thermal insulation here that I know of. No. Okay, so if I'm working with the floor, I'm going to use floors because that's an element that belongs to the floor. I'm going to use extrusion. I'm going to pick, I think grid C will be better. Before I picked grid A, so I think now grid C is the right option. And I'm going to create a thermal insulating material starting here and then there. And I'm going to create like a 4-inch thermal insulation here and there. Okay, we go to the 3D view, and now we are in this grid line. So we have to go all the way here, and we have to start there. There you go. Okay, I select this. I can change the material, and I can use rigid insulation. If you type insulation, okay, so we can use either this one, exterior, or rigid. I will use rigid insulation in this case. Okay, and that's it. So now this material is thermal insulation. I go to section 2, and now I need to cover this thermal insulation with something made of wood. So I'm going to create another architectural component, model in place. This can be structural framing because it's made of wood. And now I'm going to use extrusion. I'm going to select grid C again. And here, I just want a rectangle from this point to that point. Where is it? It's here again. And I select this, I change the material, and that material is going to be the softwood. Okay, finish model, and there you go. Okay, so between these two columns, first I placed this. Okay, so I place this element first. Second, I have this thermal insulation. And third, I have these wooden elements. So now I have the joists. The joists are resting on this first wooden element that I placed here. And now I need to cover the joist, and I did it with thermal insulation to prevent the thermal breach. And then I cannot expose thermal insulation to the outdoors. So I need to create that wooden element, and I will, yeah. So that's the exterior finish of this. So I will create this wooden element there. Okay, so if you look at this, you see that we have this wooden element here. Here you see that we have two different materials. Probably we zoom in. Yeah, you can tell that here we have the first material. This can be the rigid thermal insulation, and that's the wooden element that we created to cover that. And what's this? So that's that's extra thermal insulation, because yeah, thermal breaches are important. So in passive house, the main goal is to prevent thermal breaches from happening. So this is an extra thermal insulation that it's between the joists. Okay, and this doesn't have to be rigid. Rigid insulation works well if it's exposed to the outdoors, but this is indoors. Okay, so we have the first layer of thermal insulation here. This can get wet because it's exposed to the outdoors. We can have some infiltration, but if we have this with the fiberboard or the cellulose, that would be harmful for the material. So that's why we need the first layer, a couple of inches or 3 inches. I don't know how much, or 4, I don't remember how many I used here. And then that protects the internal thermal insulation. So the bulk of the thermal insulation, the most of the material is here, but it's indoors, protected by water leaks or infiltration that we can have from outdoors. So now we have to do this. So to do that, I need to work with a different plane or with a different section. And if I'm on level, I can get rid of all these dimensions. Now I have to work on, let's use either this grid number 1 or this grid 1.5, which is between 1 and 2. And but I have to look at the building from this part. Okay, so here I have the joists, and I need to fill the space between these joists with thermal insulation. Okay, so let's go to again to architecture component, model in place. I will use floors because that belongs to the floor. Okay, and I'm going to use extrusion, and I just want to trace the, first I need to set the work plane at grid. It can be grid 1 or 1.5. Let's place it at grid 1.5. And now I want to trace the space or the shape of this joist that I have here. Okay. So once I have a closed loop, I can copy this to the other joists. So that's important that we have the same distance between all the joists, because otherwise, if we don't have this, we can't copy all these elements here. Okay, so now I have all these shapes. I click OK. And on the 3D view, I see where am I? Okay, so I'm here, and I have to move all this stuff. Okay, so there you go. I have to move this up to the edge of this. And what's what is this distance? The thickness of this can be a couple of feet. Well, something like that. Okay. So now I have this thermal insulation here, and this can be cellulose. So if I want to change the material, remember that when you finish this option of the component model in place, we can't change the material unless we edit in place. We select again all the stuff, and now we can change the material. Do we have cellulose? We don't. Okay, so I'm going to create a new material. If I don't have cellulose, I can use something similar. But okay, so let's create a new material. I can create new material. The name, I'm going to name it cellulose. And the graphics, the color by default is grayish. I'm going to use something like that. Okay, so now this material is made of cellulose. If I use consistent colors, there would be, yeah, so this is the color that we have created here. Here it's yellowish. Okay, yep. Do that last part. The what? How you did the cellulose to create the new material. Yeah. So this is where we left. So now we have this cellulose filling the gaps between the joists. The same thing we had here. Okay. And well, I created the OSB material because the top of this floor and even the ceiling, it's an OSB board. Okay, so you see that we need a horizontal plane on this first floor, and we need the ceiling here. In some basements, we can see the structure, but on the floor, we need something, yeah, we need a board. So what I'm gonna do is to, let me see, yeah, so I'm going to place the board on this floor. So if I go to level 0, I'm going to select architecture. I can select a floor, but I think a component model in place will work better. That's a floor, of course. And if I use extrusion, I can start here, and then I can finish, let's say, there. On the 3D view, what's the thickness of the OSB material? Well, again, when we are not finished with this, we can control this. Okay, so I can select that this is 1 inch. So I can change the thickness of the extrusion, and this is 1 inch. But then I have to move it. Remove constraint. I can move it up. So I have 1 inch here. What about the material? I haven't placed any material yet, but if I don't finish, I can use by category, and I can use the OSB that I created before. Okay. So that's the OSB board with this brand there. But that will be the board. Okay, so the same board that we have here. Okay, so you can do the same here at the ceiling, but that's up to you. If you want to do it, do it. If you want to leave the basement like this, well, we shouldn't, because here we have the cellulose. So cellulose is something that we have to hide. Okay, let's do it again. So now I'm going to level 0. I'm going to do exactly the same thing. Architecture, component, model in place, floor, extrusion. Here, I don't have to set the work plane because by default, we have level 0. Okay. And now I'm going to create another rectangle from this point to that point. I go to the 3D view. The extrusion, I want 1 inch because that's the thickness of this. And the material, I want OSB. And now the placement on section 2. Okay, so I have to move it. No, I think it's in the right place, but now I'm inside the wall, so I have to drag it here. And now it will work better. Yep. So we have to start this where the wall starts, and now I have a ceiling made of OSB. Okay, so this is what residential construction is. So we have like a hollow slab made of joists. I have some thermal insulation when I get to the wall so that I don't have a thermal breach here. But that's it. Okay, so it's very cheap, very light. Okay, so now we have this floor, and this is we have all the elements that we have here. We have the ceiling, the floor, the joists, and we have this filling cellulose between joists when we are close to the wall and we don't have any thermal breach. Okay, so now we have to start working with the wall. So, okay, so look at this. There is like, we have this wooden element again. Then we have a board. It seems like an OSB board here. And then there are some rafters or some elements because we have a cavity here. And in this cavity, we can place some thermal insulation too. And probably this is what we will do. Then we have rafters or studs. And within those studs, we have thermal insulation. And then the finish, apparently we have more thermal insulation here. And then we have the external finish, the siding or the, okay. So we are not just going to insert a Revit wall. We are going to do that step by step using all the materials, assigning textures, and then on the other side of the wall, we will open the window. But so far, we're going to create an opaque wall without any windows here. And then we will open the window. Well, I told you that probably I would have to move these beams, or I would have to move the level. Okay, so in section or on this 3D view, now this floor. Okay, so look at this. If I go to annotate, no, I have to annotate in the section. So the distance between the floor, that's the floor level, and that's the beam. So the free distance is 7 feet. It's not enough. Minimum, it has to be 8 feet. But 8 feet is very low. Okay. So I think I'm going to move all this level. Well, I can move it or I can change the elevation. So I'm going to move it a couple of feet up. So I'm going to do, I'm going to move it to level 12. And everything that is connected to level 12 goes up when I change the level elevation. So now the distance between the bottom of the beam and the top of the floor, it's more than 9 feet. Can be more. So I'm going to move it to 13 feet. And I'm going to name it level 13. Okay. So yeah, I think 10 feet should be the minimum free distance between the top of the floor and the bottom of the beam. Okay. So now we have to start with the wall here. Well, that depends. In this case, I have done or I have this because I adapted the size of the column to those elements. Okay, that's fine. If it were a square, probably it would be easier. But now I have to take into account this, that this column stands out from the wall level. Well, it's not a big deal, and I will make the most of it. But yeah, we have to keep that in mind, that we are that we don't have this up to that level. By the way, well, look at this. That's the floor slab. That's the element that I have to hide this thermal insulation, this rigid insulation. I'm going to move it up, and I'm going to align these two lines. Okay, that looks nicer. Yeah, so I don't have this gap between this element and the floor. So now I have a good connection. So we're in section 2. So let's try to understand what we have here. Okay, so you see that this is the wooden element that I have just extended, and this is the OSB board. So I have the same connection here. So next, I have this, the same element I had here. I have it here. So let's do it. Okay, so I have this element here. I did it with a component model in place. Now I can copy this, but I think there is something better. If I select this element here and I edit in place, and now I select this again and I edit extrusion, now I can copy this at the top of this element. And when I do this and finish the model, I have created exactly the same element. Okay, so I can copy the element itself. So I can select this wooden element that I created and copy. But I think if I change the extrusion, it will work better. And well, other years, we have had trouble copying elements that we have created with these option extruded or component model in place extrusion. So I think that works better. Maybe I'm wrong, but I think that works better. Okay, so I'm going to do it again. So remember that we had this here, and now to start the wall, I need the same element there. Okay, so in the section, I can select this, I can copy, and I can move it up. But sometimes that, if it's a component model in place, it gives some, yeah, so we have some trouble doing that, and sometimes, yeah, it doesn't work well. So I think it's better to change the extrusion. So I select the element that I want to copy, I edit in place, I select it again, I edit extrusion, and now I can copy these pink lines here. And when I finish, so I have, well, it has a setback. Now I can select two separate elements. So I have to select, this is one element, but I think it works better as long as the both elements are the same size, the same shape, and we're not going to do something different with this one or the other one. Anyway, I don't mind how you do it, but the thing is that we need this here, okay? Then we need those stats. The stats are these vertical elements. And now it's important because we have made a decision of the distance between joists. We have to be consistent between the distance, with the distance between joists and the distance between stats. Okay, so it should be the same. So now, if I go to level 0, I know where the joists are and what kind of stats. Okay, so we have here a 1 foot element. Let me see. Oh no, this is a 4-inch. 4-inch. No, it's not 4 inches. The thing is I can't select the linear. Okay, it's 10 inches. Now that makes sense. So I can, and what's the width of the joist? Why can't I? Okay, so it's 1/3. So I'm going to create stats, a 2-inch stat, and the width is going to be 10 inches. Okay, so I'm going to create stats 2 by 10. I can create component model in place, or just to do something different, I'm going to create a structural elements. So I'm going to go to structure. I can select column. And what options do I have here? So I have the, okay. So I have this glue lamp southern pine, concrete columns, concrete round columns, and W shape. I'm going to insert a new family. So let's go to insert, load family, and in wood, okay, I have structural framing. No, I want structural columns. We can select structural columns, wood, and here we have this lumber glue lam. The glue laminated is the one that we use, but this is for structure. We have timber column and this parallel. Okay, so select this dimension lumber, open, and now we have to select one of the, okay, select the first one, and then we will edit type and we will change it. So now in structure column, we have the dimension lumber 2 by 3. We want to edit type, we want to duplicate, and this is going to be 2 by 10. So B, let's make it 2 inches, and this dimension, let's make it 10 inches. apply. By pressing the space bar, see that you can change the orientation. So in this case, we're talking about this orientation. It has to be here, aligned with the edge of the, and now where the hell is that? Oh, it's here. Okay, so be careful because Revit always plays, especially columns, wherever it feels like. So the top level in this case is level 13. The base level is level 0. And let's look at the section. Okay, so the level is not level 0. You see that we have to move it up, okay? So what is the base offset? Is it 1 foot? It's more than 1 foot. Okay, so you see that it's here. We have to place it at the top of this board. So I can measure, or I can keep going. Let's say 1 foot and 2 inches. Not enough. 1 foot and 3 inches. Yeah, that's it. Oh no, because I have to place it at the top of this level. Okay, at the top of this element that I have created here. So this is 2 inches more. So it's 1 foot and 5 inches. There you go. Okay, so you see that now. What do we have? Going to use thin lines. That's the wood element that protects the joists. This is the second wood element that I need to start the stats. And now I have the stat here. So the base offset is, in this case, is 1 foot and 5 inches. It might be different. If you have done exactly the same thing I did, you will have the same. If you have not, you have something different. At the top, we have the same issue. Okay, so we cannot go through this. So we have to create a top offset. So the top offset, let's make it -1. I don't think, okay, so it has to be lower than this. So -1 and 3 inches. No, it's gonna be -1 5 inches. Yeah, -1 5 inches. Okay, because I can't go through this beam. Okay, so now we have stat that starts at the top of this and it ends at the bottom of this beam. And now I don't need a stat here because that vertical structural element, it's just what I need to finish this wall. Okay, so I don't need a stat right there. So I have to copy those stats at the top of every single joist. So if I select this and I go to level 0, now I have to copy. So select this side of the joist and go all the way down. There you go. And now on the 3D view, this is what we get. We get all the joists, right size, and right distance. Well, these are not joists, those are stats. Joist, it's something horizontal, stat, it's something vertical, but the idea is that the distance between joists has to be the same as the distance between stats. Okay, so that's first step. If we look at the model, we have the stats here. You see that here we have something slightly, well, slightly much thicker than this, because when we open a window, again, we need a frame. We need a structural frame. So we need a horizontal element here, another horizontal element there, and we need a vertical element there. In this wall, we don't have any openings. We don't have any windows. So we just have stats, and that's what we have done so far. Okay, what's next? Between the stats, I have this thermal insulation. So if it's not exposed to the outdoors, because we have the siding here, we have the rain screen, we will have more thermal insulation outdoors. Here, we're gonna have the cellulose again. So now we need to fill those stats, the distance between the stats, with cellulose. So let's do it. We can go to level 0 again. And I think for this one, I'm going to use a component model in place. So let's use architecture, component, model in place. This is a wall. Okay, so everything I'm doing here is a part of the wall. So I'm going to select the wall category. And I'm going to select extrusion. And I can use rectangles. The first rectangle is like this. The first rectangle is going to be slightly different than the rest of the rectangles. Okay, so I'm going to create 2 rectangles here, and now I can copy this. I don't like. Okay. Yep. At some point, I made a small mistake, and probably the distance between those stats is not exactly the distance that I wanted. Anyway, I'm going to keep going, but it's not perfect. Okay. So I have all these rectangles. I can click finish. Before finishing again, I change the material to cellulose. And now I have to go to the 3D view and drag the right height up to the bottom of the beam and finish. Okay, so now if you go to the realistic textures, we have this cellulose here, we have the stats, we have the cellulose, and yeah, it goes. That's interesting because if I have the section and I use again the realistic views, you see, if we look at the cellulose, and this is the thermal insulation, that's the rigid insulation that we have here. Okay, so we don't have a thermal bridge. There might be a thermal bridge here because of this element, but structurally we need this. Okay. No, this has to go up here. Yes. So that's what I mean. Probably there's a thermal bridge here, but it's very difficult. So I can solve this thermal bridge then with the exterior siding, and I'll do that. Okay. But here we have cellulose. That's the rigid insulation. That's cellulose. I might have a small thermal breach here, so I have to fix it later. But we're on our way to do that. And here, yeah, if we don't do anything, there will be a thermal breach because of this beam, because we interrupt the cellulose here. Okay, so we have to, then when we're working with the second floor, we will have to do something. Okay, what's next? A lot of things. Now we have to either work with the interior finish or with the exterior finish. So for the interior finish, the first thing we have a board. Okay, so that's the OSB board here. And then we have those studs. And you see that the distance between these internal studs, they are very thin, and they are nailed to the studs, the vertical studs that we have here. And then we have the interior finish. So the interior finish can be a gypsum wall, or it can be another plywood or whatever, but that's the interior finish. And we have a cavity, and that cavity goes well because it helps me work with wires or small pipes or whatever. So we always have like a cavity here inside. And I can fill this cavity with thermal insulation. That's a good thing. Or we can use this cavity for wiring the whole house. So it will be hidden behind the internal finish. Okay. So let's do it. First, we have a board. So let's do it now. And then on section 2, I will have a board here covering the cellulose. Okay. So let's do it. We have architecture component model in place. This is a wall. I'm going to use extrusion. Now the grid is one of the letters. I can use grid C, for example. And I'm going to draw a board a ½ inch. This is 1 inch. I need a ½ inch board here. Okay, finish. Where the hell is it? Oh, it's here. Yeah, move it there. The material is OSB. Well, by default, I have this material, OSB. And I have to move it up to the other. I finish. Yeah. And we have this OSB board here. Just something very thin, ½ inch. That's all we need. So this is the first layer. This is the OSB that we have here. Then we need another stud. Okay. So this seems to be like a 2x6 stud in this direction. Okay, so let's try to do something like that. And now on, we can start on level 0. So that stud is here. So I can use structure column. This is the 2x10. I think we have this 2x3. Okay, so let's use this 2x3 stud and let's place it here. I think that's the right size. But now again, where the hell is it? It's the basement. Okay, so we have to go to level 0. The top level has to be level 13. And the base offset, I think it was 1 foot and 5 inches. Okay, so that's the stat now. It's not 1 foot and 5. Let's say 1 foot and 3. Yeah. And then the top offset. Let's make it negative 1 and 3. Yeah. Negative 1 and 5. Negative 1 and 4. Well, let's make it 1 and 5. Okay, so that's the stat that we have here. And we need to copy this. Yeah, I need to copy this as many times as other stats. So we can, okay, I'm going to do an array because I think it's faster. So I'm going to click array. How many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number 12. Move from the first to the last. So the first one is in this midpoint, and the last one will be at this midpoint here. There you go. So now I have 12 stats in the right place. Okay, so I can leave this as a cavity, as an air cavity. And again, if I need wires, small pipes, I can make the most of these 2 inches. Every time I have a wire, I have to perforate the stat, but it doesn't matter because this is not structural. Okay. So that's very useful, and this is usually what we get. And then we will need the internal finish. I'm not going to do the internal finish yet because I want to keep going with the exterior one. Okay, but now we're getting there. You see that we have the stats, we have the cellulose between stats, then we have the OSB board, then we have these other stats with a cavity, and the only thing I need is another layer. It can be gypsum wall, or it can be a drywall, or it can be plywood, or whatever. But I'm done. I'm almost done with the interior finish of this wall. Now let's take a look at the exterior finish. So for the exterior finish, I don't see quite well here what goes on. We know that we have a rain screen, a ventilation cavity, but I think in this case we have more than that. So first, we will need another OSB board here. So with that OSB board, I need to cover the cellulose. Okay. So let's do it. So here again in the section, that's the no, that's the model group. That's the OSB board. Okay, so I have to copy this outside. I can do another one, or I think it will be easier if I edit in place. I select it again, edit extrusion, and now I'm going to select all the pink lines and copy here. And if I do that, there will be always be outdoors. Okay, so the one that the OSB board that it's exposed to outdoors. Well, we have rain screen and we have a siding here, so we will cover this, but yeah, it needs some waterproof. So that's it's waterproof. If you go to the Home Depot, probably you can find, one of these OSBs board or particle board or whatever that has this rain screen, or not rain screen, but this waterproof element or air barriers or whatever. So industry provides us with these kind of boards, okay? So that means that it can be exposed to the outdoors. If some water gets here, we have this layer and it gets rid of the water, okay? So indoors, usually we don't need this. Outdoors, we do. This is for roof heating. In roof, it's even more demanding, but even in the exterior OSB board, we can have something like that. We can use another texture that we need to understand that there are OSB boards, or it might be different, the one facing indoors and the one facing outdoors. But anyway, we have this board, and now here we have a problem. I did it on purpose because that structure is thicker than the wall itself. So at some point, we need to prevent, so there's some issues here. First is the thermal bridge, and then it's the geometry itself. How do I solve this? Okay, so I have all the stuff here with the stats, but now this column is thicker than the wall itself. So I did it because I have this hanger. So for this hanger, I needed this dimension, but now so I need to do something here. So what can I do? Okay. So I'm going to use like horizontal structural elements between columns. I'm going to do it, and then we'll see what happens. Okay, so I need to, I have this wall here, and those are the rafters, but this is the thickness of the column. Okay, so I'm going to use structural elements. Structural, they are not structural, they are stats, but I'm going to use those stats there. And they're not stats because they are horizontal. Okay, some horizontal wooden elements, and the thickness can be 2 by 3. I remember that in structure column, I inserted column. In columns, I have this 2 by 3 dimension lumber column, but now it's not a column, it's something horizontal. So I have to insert, again, another family, and I'm not using structural columns. I'm going to use structural framing. And in structural framing wood, I have this dimension lumber. Okay, so it's the same, but this is horizontal, it's not. So I'm going to insert this dimension lumber, open, insert this 2 by 3, that's what we need, and then we click OK. And what the hell is that? Are not the structural columns. Do you want to retry loading new set of files? No, because I don't want a structural column. Maybe because we are on level 0. I'm going to go to section 2, load family. That is structural framing, wood, dimension lumber, 2 by 3. Okay. Yes, if we are on a floor plan, Revit understands that you want to insert a column. So if we are in a section, we can insert a horizontal element. Okay, so now we have to go to architecture, to structure, beams, because now we are in beams. Select a grid line, let's select grid C. And here we have the dimension lumber 2 by 3. This is what we have inserted here. And where is it? Well, I don't know. Okay, it's there. Yes, so that's what we need, but not in this direction. So we need to work with one of the elevations. In this case, I'm working on the west elevation. I don't know which elevation you are working with, and we don't see that because the elevation marks are out of the scope box. Okay, if I'm in the west elevation now, I would be able to see that. And is it? Oh, because probably on this elevation mark, if I click here, no, I should be able to see everything. I don't. Okay, I don't know what's going on, but if I create a section here looking this way, now on this section, I can see all the elements that I have created here. Okay, so why am I doing this? Because I want to insert the element, the horizontal element that I have created. So I have to go to structure, beam. Now I'm going to select the grid line 1. And just I want a beam from this point to this point. And now it's in grid line 1. That probably is not the correct grid line. Oh, yes, it is. Okay, it's there. See? So I have to move it there. That's what I want. Okay, so I want this. To go from that grid line to that grid line. Okay, but I want to start from the bottom. So on section 2, I can select this. I can move it, remove constraint, and I can move it here. Okay, so that's what I want. And now I have to copy up to the beam. So I can go to section 2. I can select this. I can use the array. And the number, we can use, let's say 10. From the first, I click on this point. To the last, I click on this point. There you go. We're going to stop here today, but we're not done yet. Okay, so it's good that we're doing this because you know what it takes to build a simple wall. So we have this kind of walls everywhere in this kind of residential buildings, and the amount of materials and the amount of decisions that we have to make is a lot. Well, this is a good wall because we are solving thermal breaches and all that stuff. Okay, so in residential buildings that you can find in Winchester Street, probably you don't have this level of quality and materials and thickness of thermal insulation and thermal breach consideration. But if we want to, if we are committed to build good buildings, well, we need to do all these elements.